Okay, excuse me, here are the solutions for your multiple choice questions for 6.6 and 6.7. Actually, it's 6.6 and 6.8. The wrong section numbers. We skipped 6.7 for now, and not that that really matters. All right, so let's see here. That's not just an x under here, so we could do u substitution, but I want you to see what happens. This is just a plain old x, so the u substitution is just going to change. It's just going to make a shift here, basically. So we let u equal x plus 1. du is just equal to 1 dx. So that's a straight swap there. That means this turns into the integral from, u numbers are x plus 1, so that goes from 1 to 9 now, of 1 over the square root of u du, and in a little bit more calculus-friendly notation, that would be u to the negative 1/2 du. Antiderivative of u to the negative 1/2 is be u to the 1/2 times 2 over 1 from 1 to 9. And I like to factor that number out. It would be 2 times 9 to the 1/2 minus 1 to the 1/2. That's 2 times the square root of 9 is 3. The square root of 1 is 1. 2 times 2 is 4. That's D. This is kind of a tricky one. I like to slip ones like this in every once in a while. You could try u substitution, but there's nothing outside the square root sign, so that's not going to work. And maybe you realize, algebra-wise, that x squared minus 2x plus 1 is x minus 1 squared. Right? If you see something like that, you think maybe you should factor, so that is what works here. The square root of x minus 1 squared is just x minus 1. And if you're thinking to yourself, well, shouldn't it be like plus or minus, or like maybe the absolute value, right? That would be true, but since we're just going from 0 to 1, we're going to get, well, actually, let's look at this. From 0 to 1, if we plug in 0 in here, we plug in 1, yeah, we've got all positive numbers here, so we're okay, I think. So that's just this. And the antiderivative of x is x squared over 2. Antiderivative of 1 is x from 0 to 1. That's 1/2 minus 1 minus, when you plug 0 in here, you just get 0, so that's negative 1/2. So a little algebra trick there. Okay. This is cotangent, but they've set it up for us here to remind us that it's a it's going to be a u substitution to get that. And also, looking at these, all the answers have natural logs in them, so that should make you think that after the u substitution, it's going to be like a 1 over u or something like that. So the substitution is u equals sine x, du equals cosine x dx. We've got that here, so that turns into the 1 over u du, right? And then the new numbers here, our substitution is u equals sine x, so sine of pi over 4 is the square root of 2 over 2, and the sine of pi over 2 is 1. So it gives me natural log u, that's the antiderivative of 1 over u, right? Square root of 2 over 2 to 1. That's the natural log of 1 minus the natural log of the square root of 2 over 2. and natural log of 1 is 0. So that's negative natural log square root of 2 over 2. Now the tricky thing here is, if you look, that is the right answer, or a version of the right answer, but it's not anything that shows up here. So there must be some kind of logarithm simplifying that I can do here. And I could bring that in, right, the negative sign. Negative in here would flip that, so that's negative. When you raise this to the negative 1, it flips it over. And 2 divided by the square root of 2 is just the square root of 2. So that's equivalent to A. So watch out for, we've seen that before, right? Having to simplify logarithm expressions. Okay. Here we've got a piecewise function. It's 8 minus x squared between negative 2 and 2, and x squared everywhere else. And then we want to find this, from negative 1 to 3. Well, let's see. From negative 2 to 2, so as you go from negative 2 to 2, for this part of the interval, it's going to be this, right? And then from 2 to 3, it's going to be the area under this one, right? So we actually have to do 2 integrals here. We have to do the integral from negative 1 to 2, that's all inside this part of it, under 8 minus x squared dx, plus the integral from 2 to 3, we have to use this part of the piecewise function. That's under x squared. Alright, so let's see if we can do those. I'm trying to cram it into this little space here. So here, the antiderivative of 8 minus x squared is 8x minus x cubed over 3 from negative 1 to 2, plus this antiderivative is x cubed over 3 from 2 to 3. Alright, see if we can simplify that. Well, we've got, plugging the 2 in here, that gives me 16 minus 8/3 minus, plugging the negative 1 in, negative 8 minus negative 1/3, right, that's this, plus 3 cubed is 27 divided by 3 is 9 minus 8/3. Let's see if we can simplify that. I've got 16 plus 8 is 32 minus 8/3. There's 3 minus signs there. We've got to be careful here. It'll be minus 1/3. So minus 8/3 and minus 1/3 is minus 9/3 or minus 3. So I've got 24 minus 3, that's 21, plus 9 minus 8/3 is, let's see, that's almost 3. This is 27/3, so that would be 19/3. So, and that's what? That's 6 1/3. So that's 27 1/3. That's in between 24 and 23. Sorry, between 24 and 32. That's D. So that's what you do with a piecewise function. You just have to look which pieces to use, and if it overlaps, then you got to break it into 2 integrals. Here, let's see, what's the derivative of this? Oh, this is the easiest kind of problem there is. The derivative of a function that's defined in terms of an integral, the x just drops in, it's e to the negative x squared. All right, fundamental theorem, part 1. All right, if f of x is equal to this, another function defined in terms of an integral, which of the following is false? Is f of 0 equal to 0? Well, let's see, f of 0 would be the area from 0 to 0, so that would be true. Is f continuous at x for all x greater than or equal to 0? Is that true? Well, the only place where this has some kind of issue would be when this is equal to the cube root of negative 2, right? When this is 0 on the bottom. And let's see if that is true. So is it true for all x greater than or equal to 0? Yeah, it is, because the value that would make this equal to 0 on the bottom is negative, right? So it's not a problem when we're greater than or equal to 0. Is f of 1 greater than 0? Would the area from 0 to 1 under this thing be positive? Well, I guess if this is above the x-axis, it would be a positive area, right? And when f of 1, so from 0 to 1, yeah, this is all positive, right? So that's also true, right? Because we just determined that the place where this crosses from being negative to positive is at the negative cube root of 2, right? So as long as we're above 0, this function is positive, and that means we got positive area. Is f prime of 1 equal to 1 over the square root of 3? Well, the derivative of this function, f prime of x, is just what you get when you drop the x in there, right? The derivative of an integral, just like the last problem. It's just that. So f prime of 1 would be 1 over 1 cubed. It would be 1 over the square root of 3, so that's true. So it looks like maybe this is the 1. That is not true. Is f of negative 1 greater than 0? It's not, because if you go from 0 to negative 1, that's running the area backwards. So although the function is still above the x-axis, since we're running the integral backwards, this one would be false, because we're going from 0 to negative 1, and that flips the sign. All right, if f and f are continuous functions such that f prime is the derivative of this, which is also like saying this is an antiderivative of that, right? Then for all x, well, if this is an antiderivative, then by the fundamental theorem part 2, that is equal to f of b minus f of a, right? That's what the fundamental theorem says. And that's straight up asking fundamental theorem. What you need to recognize is this is saying f is an antiderivative of f of x. This is saying the same thing, and it's often presented like this. How do you recognize that? Well, if you took the antiderivative of both sides, then you get antiderivative of this is equal to antiderivative, and derivative would cancel out. It's just the capital F function. So that's fundamental theorem. How about this? Well, this looks like a U substitution. I think that could be an inside thing, but it looks like that's going to be the one that works. So U equal x squared plus 2x. Du is equal to 2x plus 2 dx. Now I don't have 2x plus 2, but I have x plus 1, and that's 2 times this. So that means I need a 2 in here and a 1/2 on the outside. So making the substitution, get 1/2 is the integral from, using my substitution, 0 would turn into 0, and 1 would turn into 3. And then I have, let's see, the 2 times that times dx, that's all the du. And I get e to the u. And the antiderivative of e to the u is e to the u. Don't forget about your 1/2. And from 0 to 3, it gives me 1/2 times e to the 3rd minus e to the 0. Now that's, since e to the 0 is 1, I think that matches up to this. Let's see. Oh, this is a tricky one. There is no use substitution you can do here. Let me show you the trick that's going to work for this one. Remember your Pythagorean identities. Sometimes you have to use trig identities to simplify these things. What we wish is that if that were secant squared, then I could do something with that. Remember, that's your Pythagorean identity, number 1. But if you divide everything by cosine squared, you get another version which says sine squared over cosine squared is tangent squared x plus cosine over cosine, so that's 1, is equal to secant squared x, which means that tangent squared x is equal to secant squared x minus 1. That's what's going to do it for us here. So this is not a u substitution, it's just a trig identity. So tangent squared, same as secant squared minus 1. Now I can take the antiderivative. The antiderivative of secant squared, is tangent, and the antiderivative of 1 is x, from 0 to pi over 4. So that gives me tangent of pi over 4 is 1, minus pi over 4, that's plugging pi over 4 into that, minus tangent of 0 is 0, minus 0. So that's 1 minus pi over 4. Right? And the u substitution. You might think that matches up to sine inverse, but not with 2x on the top. That makes it a u substitution. U is equal to 1 minus 2x squared. Du is minus 2x dx. And I've got the 2x there, I just need a negative sign to make that match up. So that now looks like negative integral from plugging 0 in here, I get 1. Plugging 1/2 in here, 1/2 squared is 1/4. 1 minus 1/4 is 3/4. And then this all turns into 1 over the square root of u du. And you notice that these are backwards, and I have a negative, so we could switch those and cancel out the negative sign. That's u to the negative 1/2. So the antiderivative of u to the negative 1/2 is u to the positive 1/2 times 2. I'll put the 2 out here, from 3/4 to 1. Let's see if we can get it simplified. So that's 2 times plugging 1 in. 1 to the 1/2, the square root of 1/2 is just 1. The square root of 3/4 is the square root of 3 over the square root of 4. That's distributing the 2 minus the square root of 3. 3, which is e. Here, we'll let the u equal x squared, so du is equal to 2x. Oops, that's not going to work. So, there's something else we can do here. So sometimes the first thing you try doesn't work. That didn't work because I have an x there, but there's the minus 4, so what are you supposed to do with that? But this one, since we just have one denominator, I can divide through, right? So x divided by x squared is x to the negative 1, and minus 4 over x squared is the same as minus 4x to the minus 2. And maybe I should have left that as 1 over x, because the antiderivative of 1 over x is natural log x. And the antiderivative of this would be minus 4x. That goes up to negative 1, and then I divide by the new exponent. Dividing by negative 1 makes that positive, from 1 to 2. That gives me natural log 2 plus 4 times 2 to the negative 1, that means 4 over 2, or 2, minus natural log of 1, which is 0, minus 4 times 1 to the negative 1 is just 4. So that's gone, that's 0. So it looks like I have natural log 2 plus 2 plus 4. Uh-oh, did I make a mistake? That answer is not there. So, in case this happens to you, go back and check your work. So let's see. X over x squared is x to the negative 1, negative 4, x to the negative 2. That looks good. That's the right antiderivative of that. Maybe I messed this up. Exponent goes up 1 to negative 1, divide by the new exponent. That looks also correct. Natural log of 2 plus 4 times 2 to the negative 1 is 2. That looks okay. Then plugging 1 in, natural log of 1 is 0. Plus. That's the mistake there. That should have been plus. Right? I was thinking about subtracting here, I think. But that should have been plus. So that's 2 minus 4, which is negative 2, not 6. And that's B. Right. That's a nice thing about multiple choice. You catch your errors sometimes. Another piecewise function. So it looks like from negative 1 to 0, I'm going to have to use this one. And then from 0 to 1, I'm going to have to use this one. So I have to break it into two integrals. From negative 1 to 0, I'm underneath this, right? Because this is the x is less than 0 part. X plus 1 dx. And then from 0 to 1, I'm underneath cosine pi x dx. Right? So let's see if we can get an answer here. I'm going to go ahead and grab a piece of paper. I've got quite enough room to do that. So let's see. Antiderivative of x plus 1 is x squared over 2 plus x from negative 1 to 0. Antiderivative of cosine of pi x is 1 over pi times the sine of pi x. You can do a u substitution there and figure that out. That's just a multiple of x, and that's what happens with those. You can go ahead and write out the substitution if you like. And that's equal to plugging in 0 into this gives me 0, minus plugging negative 1, that gives me 1/2 minus 1, plus 1 over pi times the sine of 1 pi, the sine of pi is 0, minus the sine of 0 pi, which is also 0. So it looks like this whole thing cancels that to 0, and I get 1/2 minus 1 is negative 1/2. That would make it positive 1/2. And yay, that's an answer. Alright. This is one, I think like the very first one, where you can write out the u substitution, but it's basically just a shift, right? U equals x plus 1, so then du, the derivative of that is just 1. So when you rewrite it, it just looks like, with the new u numbers plus 1, it's from 1 to 4 now, of u to the 1/2 du. The antiderivative of that is 2/3 u to the 3/2 from 1 to 4. That's 2/3 times 4 to the 3/2 minus 1 to the 3/2. And that's 8 minus 1, which is 7. That's 14/3. If n is a known positive integer, for what value of k is the area from 1 to k under this equal to 1 over n? Well, Let's see, that might be worth a little bit more space. Try to set that up. Let's just try to do this and see what happens. The antiderivative of x to the n minus 1 would be bump the exponent up 1 to x to the n and divide by the new exponent. So the antiderivative of x to the n minus 1 is x to the n over n, from 1 to k. So that would be equal to, plugging the k in, that would be k to the n over n minus 1 to the n, and 1 to any power is just 1 over n. And I want that to be equal to 1 over n. So that means k to the n over, oops, sorry, I don't know why I write 1/2 there. That should be an n, right? They told us it's supposed to be equal to that. So adding this to the other side will give me 2 over n. And those cancel, so k to the n equals 2, so that means k would be the nth root of 2, which is the same as 2 to the 1 over n. A little tricky. And here, the antiderivative, no substitutions here, of x to the negative 3 is x to the negative 2, and divide by the new exponent from 1 to 2. It's negative 1/2 times 2 to the negative 2 is 1/4, minus 1 to the negative 2 is 1. 1/4 minus 1 is negative 3/4, so that'd be positive 3/8. Almost there. Here's another algebra trick. If you're looking at this thinking, hey, x squared minus 1 is x minus 1 times x plus 1, and the x plus 1s would cancel then. Can you do that? Well, you can do that so long as this doesn't cross over the spot where those cancel. And even then, actually, with integrals, you can probably do it. We haven't really talked about that, but it turns out like integrals under like things that are not continuous can still be defined because of the way that they're defined in terms of rectangles. So no problem doing that canceling here. So a little bit of algebra, and then so this just turns into, after the x plus 1s cancel, it's just that area. So antiderivative of that is x squared over 2 minus x. If you're thinking to yourself, hey, that's a line, I could just draw that and find the, like a trapezoid. Yeah, you could do that too, sure. If that makes you happy. Plug the 2 in. That gives you 2 squared over 2 minus 2 minus, when you plug the 1 in 1/2 minus 1. That's 0. 1/2 minus 1 is negative 1/2. That makes it positive. That's A. Here's another one with a pesky k in there. So let's see if we can make this equal to 16. The antiderivative of that would be x to the 8th over 8 plus kx from negative 2 to 2. So let's see. 2 to the 8th, and that's 2 to the 3rd, right? So 2 to the 8th over 2 to the 3rd is 2 to the 5th, or 32, plus kx, so that's 2k when I plug the 2 in for the x, minus negative 2 to the 8th is the same as 2 to the 8th, right? So that'd be the 32 again, minus 2k. So those cancel, 32 minus 32, and then I get 2k minus, so that's equal to 4k. And that's supposed to be equal to 16, so k must be 4. Here's that kind of substitution. I'll let you write it out for a minute. You can pause and write out the substitution. But every time it's just a multiple of x like this, it turns out after you do the substitution, u equals 3x, du equals 3 dx, so I need a 3 in here. You end up just having to divide, you just need that 1/3 on the outside. So 1/3, my new u numbers are 0 and 3 times pi over 3 is pi. The sine of u du, that's 1/3 times sine u, oops, sorry, didn't take the antiderivative. Antiderivative sign is negative cosine, going too fast, from 0 to pi. So that's, I'll take the negative outside, that's negative 1/3 times cosine of pi minus cosine of 0. Negative 1/3 times cosine of pi is negative 1 minus cosine of 0 is 1. That's negative 2 times negative 1/3 is positive 2/3. Okay. The derivative of an integral function, hey, wait a minute, this is just one of those easy ones. That's just the square root of 1 plus x squared. Right? Derivative of an integral, done. Those cancel each other out. Here, all these answers have natural logs in them, so it looks like we're headed for like a 1 over u type thing. So u is, if we let that be the bottom, then u would be equal to, du would be equal to 2x plus 2 dx, and that's x plus 1 times 2. So I need a 2 in here, 1/2 on the outside. So, it's going to be 1/2 times my new integral. Plugging 1 into this, I get 3. Plugging 2 into this, I get 8. So these are looking pretty promising with the 8 and the 3. 1 over u du. That's equal to 1/2 times the natural log of u, 3 to 8. And sure enough, with the 1/2 there, that's going to be equal to b. All right, 32.5 minutes. Whew. Did it.